All right, we're going to finish up inverse functions and their derivatives by looking at finding if using calculus to figure out if a function is one-to-one. This is so cool, right? Okay, so we're going to look at these functions and try to figure out if they are one-to-one. So if you remember what a one-to-one function looks like, it means that the function, when we find the inverse of it, it is also a function. The inverse is also a function. So I'm going to see if I have some space here. Actually, I'll just use the bottom of the page. How about that? Okay, so if you think about, say, this function right here, this is a function, right? But is its inverse a function? Well, its inverse would look, like this. And that's not a function, right? Because it doesn't pass the horizontal line test. We can't draw, the vertical line test. Can't draw a vertical line that only touches one point. At times it touches more than one point. So that one is not a one-to-one function. Just the same as a parabola is not a one-to-one function because it doesn't pass the vertical line test when we do its inverse. So you remember there's this thing that we do that we can say we don't even need to graph the inverse. We can just check and see if the function passes the horizontal line test. If it passes the horizontal line test, then we know it's a function, a one-to-one function, because we know its inverse is going to be a function. Because, when we reflect it, the reflection is going to pass the vertical line test. So the idea is we have to look and see, does our function, is it one-to-one? And let's think about this a little bit logically. If I have some function, and it's going along, it's increasing, 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 and then it starts decreasing for a minute, then it starts increasing, 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 decreasing, increasing. This is a function, right? It passes the vertical line test. There's nowhere on this function that I could draw a vertical line where it would touch more than one point. But does it pass the horizontal line test? Well, bam, there we go. It loses right there because I could draw a horizontal line that passes through 3 points. So this is not a one-to-one function, correct? Because its inverse is not a function. So let's think of some more. If they are decreasing, 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 increasing, decreasing, 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 increasing, decreasing, 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 is this a one-to-one function? That is a really ugly function. But the question is it one-to-one? No, it doesn't pass the horizontal line test. So for a function to be one-to-one, it has to either always be increasing or it has to always be decreasing. Because when it does that little loop-de-loop where it starts increasing and then decreasing, it creates this spot that messes with the horizontal line test. So what we're going to do with calculus is we're going to decide, is this function always increasing or is it always decreasing? And if you remember what we call that a monotonic function. This is a strictly monotonic function. That means it's always decreasing or always increasing. Okay? So again, to be a one-to-one function, the function must be strictly monotonic for its entire domain. And how do we find that? An f-prime number line! Yes! I know you love these. Okay, so let's take a look. Here we have a function, 6x minus x cubed. And we want to know if it's one-to-one. So the first thing we need to do is figure out where is it increasing and where is it decreasing. And does it do both or is it just one? So we have to find f prime. And f prime of x is going to be 6 minus 3x squared. And then we have to figure out where is f prime equal to 0, because those are going to be our critical numbers. So we set it equal to 0. And we have 6 minus 3x squared. And we go ahead and factor out a 3, and we have 2 minus x squared. Because remember, we find our critical numbers where the derivative is equal to 0. So then we set our factors equal to 0. Well, 3 can never equal 0, so all we have to set equal to 0 is 2 minus x squared. So then we solve for x, and so we subtract 2 from both sides. We have negative x squared equals negative 2, which means x squared equals 2, and then we get x equals plus or minus the square root of 2. Okay, so these are our two possible critical numbers. So we're going to draw our f prime numbered line. And we're going to put our critical numbers on there, negative root 2 and root 2. And then we're going to see what's happening with this function on either side of it. So let's start in the middle because it has 0, and I love plugging in 0 because it's so easy. So remember, I plug 0 into the derivative and see is the derivative positive or negative at that point. Well, when I plug in 0, this is positive. So that means the function is increasing at that point, right? Well, when I plug in some number smaller than root 2, than negative root 2, like negative 5, this is going to be negative. And when I plug in a positive 5, this is going to be negative as well. So, is this a one-to-one function? Nope, because we don't know exactly what it looks like without doing a little curve sketching. But think about it. It's decreasing, then it increases, and then it decreases again. So it definitely cannot be a one-to-one function. It wouldn't pass the horizontal line test. So then the next question is, what is the largest interval containing x equals 0 that f is one-to-one? Well, remember, it has to be strictly increasing or strictly decreasing on this interval. So where are we just increasing? Well, from here to here, we are just increasing, right? And x equals 0 is in this interval. So from the interval, negative root 2, wow, that went nuts. Okay, negative root 2 to root 2, we are increasing only, which makes it one-to-one. Then the last question is, where is it have an inverse function? Okay, so remember, f is one-to-one and f has an inverse function are the same thing. They mean the same thing. So you can see either one and answer the exact same question. So x equals negative 2 is way over here on our number line. Not way over, it's like kind of over there. All right, so an interval where it's just either decreasing or increasing. And we see that that's the interval from negative infinity all the way to negative root 2. Not 2 root 2, just negative root 2. So this interval would be negative infinity to negative root 2. So that's it for inverse functions.